So, good morning, dear students. Let's see the numericals on this particular chapter under the column analysis, and we have solved many numericals which is based on the Euler formula or Rankine formula. So now let's see the one another numerical. So that is the numerical. So, 2 meter long pin-ended column of a square cross section is made of wood. Okay, try to be understand that numerical. A 2 meter long pin-ended column of square cross section means that column, which column it's having the square cross section. It square cross section. Okay, it's made of wood. Wood का है. Assuming Young modulus is 13 gigapascal and that sigma all means it is assuming that the stress which is acting any cross section of that wooden column, it's at 12 megapascal. Using a factor of safety of 2.5 is computing Euler critical load for buckling. Determine the size of cross section of if the column is safely supported a 100 kilonewton of load and 200 kilonewton of load. So we have to be find the cross section of that square. The two things is given. The column is square cross section, and we have to be calculate the cross section of that column when safely once apply that 100 kilonewton of load, and second when it's applied at 200 kilonewton of load. In the both case, what will be the cross section of the column? That is the simple question. So we have Younger modulus, we have that stress the double is column, and we have two loading condition, and okay, and we also factor of safety is there, and Euler critical load formula we have to be applied here. So Euler formula is, you know, that P is equal to pi square EILE square, where LE is effective length of the column. So I already told you, when the question not mention the which type of end condition of the column. Okay, in the here it is a given. That's good. So if it is not given, so you can assume that first one. Okay, so let's see in this problem. Fortunately, we have that end condition, that is a pin end. Okay, so L is equal to L as the both end has pinned condition is given. So we assume that x is side of square cross section. X is the side of the square cross section. Okay, yeah, might be you got my point. So like this, try to be understand. This is a suppose it's a square. Okay, it's not like a square, but you assume this is square. So this is x, and this is also x. Okay, this it's mean that the side of square cross section is x. So what will be the moment of inertia if x is passing on from there? So you can say x की पावर 4, क्यों? क्योंकि अपन लिखते थे क्या, बी डी क्या बोलते थे, बी डी क्यूब बाई 12. ओके, सो हेयर क्या है, क्या हो जाएगा, बी डी क्यूब. So b is x, b is also x, and d is also x. So it's become x की power 4 by 12. You might be understand now. So this become I is equal to x की power 4 by 12. So now we have to calculate the value of x. So the question P, you can see that P safe or working is working load we can say. Safe, safely के लिए we are using that factor of safety. So this is the PE, Euler load upon factor of safety. It is said to be P safe. Okay, are you getting my point? P safe is that value where the at which that column is safe, and it is can obtain only by if you divide by PE upon by factor of safety. We have already discussed that how the utility of the factor of safety and how, why it is using. Okay, so dear, just use this formula, like this one in place of PE. So it's become, okay, in place of PE. So this formula become pi square EI, pi square EI FOS factor of safety into L, L chi square, because L is replaced by the L, and this P must not be there. So you just remove this. It is by mistakes came here. So this remove this. Okay. So this B pi square EI F factor of safety into L square. Pi square EI just replace the value of I by x cube by 12. Okay, by 12, and you put the all the values. So just we have to be calculate this value of x ki power x. So we can write this above equation in term of x. So it's become x ki power 4. So it's become 12 p, this p safe factor of safety L square upon pi square E. Okay, this is the now one equation. So this is equation number 1, suppose. So this is one of the equation. Now in the first condition said the what is the P safe value? P safe value, it's given you fly 100 kilonewton, then the your column must be safe, and factor of safety is also given, that 2.5, and length of the column is given in the question and in the modulus is given. So do one thing, put the all respective value here. What is the 12 into P? P is 100 kilonewton, and convert kilonewton into newton in 10 to the power 3. And factor of safety is given 2.5 into that length. Length is given is 2 meter, or 2 into 10 to the power 3 whole square. Okay, let's E is also given in the question, 13 gigapascal, and you can convert gigapascal into Newton per mm square, like just multiply by 10 to the power 3. So here, by this relation, you can find the value of x. Okay, so this is the we have calculated the value of x. So with the help of this, we can find the cross section. Right? Okay, so one sigma is given, sigma all. So sigma all is it is applicable to the that given column from the every cross section. Now we have to be, we are what the question saying, it must be safe. So sigma safe can become sigma x all upon factor of safety. So it's come 4.8 megapascal. Okay, so let's next. So we can say sigma safe P upon A equal to 4.8 into this. So here you can also calculate the value of x. One, you calculate the value of x by using the Euler formula, and another you can use by the using the sigma all. Sigma all is the stress developed in cross section of the wooden beam. So by using both, you have calculated two value of x. One is that this one 98.34, and one is the 144.34 mm. The larger value of x satisfy the both criteria. Okay, why larger? If you suppose you consider this one, 98.31, if this stress will develop, so that column will fail. That's why the larger of both value, we have to be take larger one. Next. Okay. So every time any question when P all or stress develop in the column or soft, it's a given, so you have to validate it also. Okay, so we have next in question, the piece value of p shape is if a 200 kilonewton of load, then what will be the cross section. So same that equation number one what we have derived, you using that you put all the respective value there like this. You can see here in this one 12 p shape f factor of 30 le pi square f the same value, but this 100 become 200 only. So it's quite obvious, you can see that. So this become new value is 116.95 mm, the value of x, which can obtain with by the using the Euler formula. Okay, Euler formula, that cross section, and it can bear this amount of load also. This can 200 kilonewton. If we are talking about the Euler formula. Next, we have the P safe, we can find, we can calculate by P upon A, where P safe now we have calculated by the stress, actual stress induced in that column, that is a 4.8. And 4.8, we know that value of P is the 200 kilonewton upon x square is the cross section or sector of that beam. And again, you have to be take the whatever the larger value. So you have to be take the larger value of both what it's come in the second criteria, that will satisfy the question, or it's also one kind of validation. And if you use this cross section, definitely your beam will save in the both condition. If applied load is 200 kilonewton and you use the Euler formula, Euler beam, and another if the stress induce sigma, that is called sigma all. So at that case also, both case the beam will save. So that is the simple meaning of that. So hope so you can understood. This is one of the good question. So such kind of question you also keep in practice. You can use any book and use the same fundas, same formula, you can easily get the concept. So for today it's enough. So thank you so much for being here.